All right, let's get cracking with this deep dive. For anyone tuning in as part of their GCSE Computer Science journey, welcome back. This is episode 3, and today we're tackling something right at the heart of all the tech we use every single day. Computer systems.
Absolutely fundamental.
Now, every computer system, right, from your mobile phone to, I don't know, a beefy gaming rig, it relies on 2 key bits working together like, well, fish and chips maybe. Hardware and software.
Good analogy, yeah.
Think about your Xbox or PlayStation. You've got the physical console, that's the hardware. But without the games, the software, it's just sitting there.
Yeah, pretty useless on its own. A fancy paperweight, like you said.
Exactly. And the newest, most amazing game, it won't run unless you've actually got the console to play it on. They absolutely need each other.
Spot on. They're totally reliant on one another. So when we talk about hardware, we mean all the bits you can actually get your hands on, you know, the tangible stuff.
Right, the physical parts.
Yeah. We're talking about things like the central processing unit, the CPU. That's like the brain doing all the calculations. Then there's RAM. That's its really fast short-term memory.
Right.
All your storage, like hard drives or those speedy solid-state drives. And, of course, the things you physically interact with, your keyboard, your mouse, the screen.
Gotcha. And then you've got software. This is the brains behind the brains, maybe?
Huh. Yeah, you could say that.
It's all the programs that tell the hardware exactly what to do. These exist on the system. You can see them on your screen, but you can't actually, well, you can't touch them, can you?
No, not physically. So that's your operating system, the thing that makes the whole computer work in the first place.
Yeah.
All your apps, like the ones you use on your phone.
Yeah.
And even those behind-the-scenes programs called utility software, we'll get into those.
Right.
And this deep dive is really about getting a solid understanding of these, well, these essential building blocks. Because whether you're playing Fortnite or writing up your history homework or just scrolling through TikTok, it all boils down to how the hardware and software chat to each other. And knowing a bit more about this can really give you a better idea of how your favorite tech actually works its magic, you know?
Okay, so we've got the basics sorted. Now let's unpack this a bit further for our GCSE crew and look at the different types of software. Starting with the big split, you mentioned system software and application software.
Right, exactly. System software is the stuff that's absolutely crucial for the computer to even switch on and operate properly. Think of it as the foundations of a house.
Okay, the foundation.
Without it, you can't really build anything else on top. It provides the platform that allows you to run all your other programs, you know, the apps you actually use day to day.
And what are the key jobs that system software does then? What's it actually responsible for making happen when you, say, turn your computer on?
Well, a really crucial one is booting up. That's the process of getting all the hardware ready to go when you hit the power button. It's like the system software is waking everything up, making sure all the different bits of the computer can talk to each other correctly. Then you've got device management. That's all about handling any extra bits of hardware you plug in.
Like a printer.
Or headphones.
Exactly. Your printer, your headphones, even your memory stick. The system software makes sure they can all communicate properly with the computer. And a big one, obviously, is security.
Yes, important.
System software provides a basic level of defense for your hardware, helping to protect it from nasty stuff like viruses or malware that could, you know, mess things up.
Makes sense. It's like the essential scaffolding, the groundwork that everything else is built on. So where does application software, or those apps we all know and use, fit into this for our GCSE listeners?
Right. So application software, or
Sure.
apps, these are the programs that you, the user, choose to install and use for specific tasks you want to do.
They sit on top of the system software. So once your operating system is up and running, then you can install and use, say, a word processor to write that English essay, or fire up a game to have a bit of downtime. It's all about meeting your individual needs and what you want to achieve with your computer.
Can you give us some examples of the different types of apps we might use every day, just to sort of nail this down for our GCSE folks?
Absolutely. You've got productivity apps. These are all about getting things done efficiently, maybe for school or other tasks.
Like Word or, well, not naming names, but word processors.
Exactly. Word processors for writing, spreadsheet software for working with numbers and charts, or presentation software for creating those slideshows you sometimes have to do for class.
Right, got it.
Then there's communication software, helps us stay in touch. Things like email apps, web browsers for surfing the internet to do your research, and messaging apps for chatting with your mates.
Can't live without those.
Pretty essential these days. And of course, we can't forget entertainment apps, things like video players for watching films, video games, obviously, and music streaming services for listening to your favorite tunes.
Cool. So system software is the essential groundwork, the foundations, and application software is what we actually use to get stuff done, whether that's learning or leisure. Got it.
Precisely.
Now, within system software, a really important bit that comes up a lot in GCSE is the operating system, or OS. Let's dive a bit deeper into that, shall we?
Absolutely. The operating system is key. It's like the conductor of an orchestra,
Well, I like that.
making sure all the different parts of the computer work together harmoniously. As we sort of touched on, it acts as the interface, the go-between between you, the user, and the actual hardware of the computer. It takes all the really complicated stuff happening at the hardware level, all those electrical signals and complex processes, and presents it to you in a way that's much easier to understand and interact with on your screen.
You gave the example of saving data earlier.
Mm-hmm.
Can you maybe elaborate on that in a way that really clicks for someone studying this for their GCSE?
Sure. Think about it. When you're working on a document for school, right, and you click Save,
Yep.
you don't need to know the specific little areas of memory on the storage drive, whether it's an old-style hard drive or a newer SSD where that data is being physically written as, tiny magnetic or electrical charges.
No, definitely not.
You just click Save, maybe give it a name, and the operating system handles all the nitty-gritty details. Where it's stored, how to find it again later when you need to open it. It hides all that low-level complexity from you.
Okay, so it's making things much simpler for us, like
Yeah.
having a really helpful assistant who just knows where everything is kept. What are the main jobs, then, that an operating system actually does to keep everything running smoothly?
There are 5 key areas, really. Good to know for your GCSE understanding. First up, it provides the user interface. That's how you actually interact with the OS, the way you tell the computer what to do and how it shows you the results.
Okay, the interface.
Then you've got memory and processor management. That's all about making sure different programs can run smoothly at the same time without crashing into each other.
Multitasking, basically.
Exactly. Next is I/O management and device drivers that handles how the computer talks to things like your keyboard, your mouse, the screen you're looking at.
Inputs and outputs, I/O. Right.
Then there's application and security management, which makes sure your apps can run properly and helps keep your system protected from threats. And finally, file management, which is all about organizing all your digital stuff, your files and folders.
Phew, okay. That's quite a list. Let's break down that first one, the user interface. Because as anyone who's used different devices knows, there are different ways we can interact with computers, aren't there? This is a good one for our GCSE listeners to get their heads around.
Absolutely. The operating system decides how you actually give commands and get information back. One of the oldest types is the command line interface, or CLI. This is where you type in text-based commands to tell the computer what to do. Think of old systems you might see in retro games, or maybe the terminal on a Raspberry Pi if you've used one of those.
Right, it's a bit like something out of a hacker film sometimes.
Yeah, it can look a bit intimidating. It's mostly used by more technically advanced users these days or for specific server tasks.
So what's good and bad about using a CLI? What are the advantages and disadvantages for someone learning about this?
Well, if you know the specific commands, it can be really fast and efficient for certain jobs. And it often uses fewer of the computer's resources, less memory, less processor power. So it can run well even on older or less powerful hardware. It's also great for automating repetitive actions with scripts.
Okay, so speed and efficiency if you know what you're doing.
But the big downside is you have to remember all those specific commands. And if you make even a tiny typing error, it just won't work. It's definitely not as obvious or easy to pick up as other interfaces. You need to learn the language, essentially.
Okay, so probably not what most of us are used to day to day. What's the interface we're probably most familiar with on our phones and home computers?
That would almost certainly be the graphical user interface, or GUI.
GUI.
Got it. This uses visual elements that you can see and interact with directly. Things like windows, icons, menus, and a pointer, often controlled by a mouse or, by touching the screen.
Right, like Windows or Android or Mac OS.
Exactly. Operating systems like Windows on your PC, Android on many phones, Mac OS on Apple computers. They all use GUIs. It's designed to be much more intuitive. It doesn't require you to memorize loads of complicated commands. You can usually just point and click or tap to get things done.
Yeah, clicking on an app icon is definitely easier than remembering a line of text for me. But are there any downsides to using a GUI for our GCSE students to consider?
Well, GUIs tend to use more of the computer's processing power and memory because the system has to constantly draw all those visual elements on the screen, update them,
Okay.
and sometimes clicking through lots of menus to find a specific setting can actually take longer than typing a quick command if you happen to know it. And for doing the exact same action over and over again, constantly moving the mouse and clicking can become a bit of a drag, perhaps.
Fair enough. Good point. What are some other types of user interfaces that our GCSE listeners might encounter in different bits of technology, not just on their main computers?
Another common one is a menu interface. This presents you with a series of menus, and you select an option at each stage, usually by pressing buttons or using a keypad.
Okay, like on a...
Think about using chip and pin machines when you're buying something at the shops, or the options you see on vending machines, or even navigating through different sections on some TV streaming services using your remote control. That's often a menu-driven interface.
So quite structured then, step-by-step choices.
Mhm.
What are the good and bad points of that kind of interface?
They're generally very simple to use, aren't they? You're just choosing from a limited set of options. They can be quite efficient for very specific tasks that don't need a lot of flexibility.
Right.
However, they're not very adaptable. You can only do exactly what the menus allow you to do. And sometimes navigating through lots of layers of menus can be a bit slow if what you want is buried deep down. Plus, they can sometimes cause accessibility issues for people who might find it difficult to see the screen clearly or use the physical buttons.
Okay. And finally, we've got natural language interfaces, or NLIs. This sounds like something a bit futuristic for our GCSE students, is it?
Well, it's becoming more and more part of our everyday tech, actually. NLIs use spoken words or even typed natural language to respond to your voice or text input in a way that feels more like talking to another person.
Like Alexa or Siri.
Exactly. Think about virtual assistants like Alexa, Google Assistant, and Siri that you might use on your phone or smart speakers. But also things like search engines, where you can type in a question in plain English, not just keywords, or smart home devices that respond to your voice commands to turn on lights or play music. Those are all using NLIs.
That's pretty cool.
Yeah.
What are the advantages of being able to just talk to your tech?
Well, they can be really intuitive, can't they? Especially for people who aren't that confident using computers, or maybe who find it easier to speak than to type. They can also be a massive help for people with certain disabilities who might struggle to use a keyboard or mouse.
Yeah, good point.
However, they're not always perfect at understanding exactly what you mean, especially if there's background noise or you don't speak clearly or have a strong accent, perhaps. And there are definitely some important privacy questions to think about when you're constantly having devices effectively listening to what you're saying. That's a big discussion point.
Yeah. Definitely something to consider. Some really interesting trade-offs there with all the different ways we interact with our tech. Good stuff to think about for GCSE. Okay, let's move on to the next job of the OS, memory, and processor management. This sounds quite technical, but I guess it's important for understanding how your computer handles everything you throw at it.
It really is. Okay, so memory management. This is all about how the operating system handles the computer's main memory, which is RAM, random access memory.
RAM, right, the fast temporary workspace.
Exactly. Think of RAM as your computer's super fast but temporary workspace. When you have multiple programs open at the same time, say you're writing an essay in one window and you've got a web browser open for research in another,
It happens all the time.
the OS is responsible for allocating chunks of this RAM to each of those programs so they can run smoothly. It also handles copying the specific bits of data that a program needs from the slower long-term storage like your hard drive or SSD into this fast RAM when it's actually needed.
So it's like a really efficient librarian for the computer's short-term memory, quickly
Yes.
grabbing the books or the data that are needed right now.
That's a great way to put it. Yeah, exactly. And it also prioritizes programs that are essential for the computer to run properly. So if your system is getting overloaded, maybe you've opened too many things,
Okay.
the OS will try to make sure the crucial bits the system processes themselves get the memory they need to keep things stable, hopefully preventing a crash. Memory management is what makes multitasking, running lots of programs apparently at the same time, actually possible on your computer or phone.
Right, so I can have my game, my chat app, and maybe a YouTube video all seemingly running at once without my phone completely freezing up most of the time.
Most of the time, yes. That's the OS doing its job.
What about processor management then? What's the OS doing with the CPU, the actual brain of the computer?
Right, the CPU, or Central Processing Unit. That's the part of the computer that actually carries out all the instructions from the software. It's incredibly fast, but fundamentally, it can generally only do one thing at precisely the same instant.
Only one thing.
At any given nanosecond, yes, but it does billions of things every single second.
Yep.
Processor management is how the OS divides the CPU's incredibly short bursts of attention, its time, into tiny little slices.
Time slicing.
Exactly, time slicing. And it allocates those slices to all the different programs that are running and waiting for their turn. This happens so incredibly quickly, millions of times a second, that it creates the illusion that your computer's doing loads of things simultaneously.
Wow.
It's like a really, really skilled juggler, rapidly throwing and catching multiple balls. The CPU is the juggler, and the OS is deciding which program's instructions, which ball, gets processed next in line for a fraction of a second before switching to the next one.
So it's like time sharing on a microscopic scale to make multitasking feel real. Clever stuff. Okay, next up in our GCSE tour, we've got I/O management and device drivers. What's that all about in simple terms?
Okay, I/O management is how the operating system handles the communication between the software you're using and your input and output devices.
Input and output. So things like keyboard, mouse, monitor.
Exactly. Your keyboard when you type input, your mouse when you click input, the monitor displaying what you're doing, output, the printer if you need a hard copy output, speakers output, microphone input, and so on. The OS makes sure these devices can send information to the computer and receive information back in a coordinated way. A key part of making this easy for you, the user, is plug-and-play functionality.
Plug and play. That's when you connect a new gadget like a USB stick or maybe a new mouse, and it just works without you having to faff around installing stuff.
Precisely. The OS can automatically detect many new devices when you plug them in and configure them, often without you having to manually install special software or even restart your computer. It makes life much easier.
How does it do that? Is it magic?
Not quite magic. It's partly down to something called device drivers. A device driver is a specific piece of software. Think of it as a translator.
A translator.
Yeah, it tells the operating system exactly how to communicate with a particular piece of hardware. Each bit of hardware speaks its own unique sort of dialect. The driver translates between the OS's general commands and the hardware's specific language.
Okay.
The OS usually has some basic general drivers built in for common types of devices like keyboards and mice. That allows for that basic plug-and-play experience.
But sometimes you still need to download and install drivers, right, from the company that made this specific piece of hardware. Why is that necessary if the OS has basic ones?
That's right. To get the absolute best performance, or perhaps to access all the special features of a particular piece of hardware, like maybe advanced settings on a gaming mouse or a high-end graphics card, you often need to download and install a specific device driver provided by the manufacturer. These drivers are often more finely tuned for that exact piece of hardware and can include extra features or optimizations.
Right.
And it's really important to remember for your GCSE that these drivers are usually specific to the operating system you're using. Windows driver won't work on macOS, for example, or Linux, and they often get updated by the manufacturers to fix bugs or improve how well the device works with newer software or OS updates. So keeping drivers updated can sometimes be important.
Okay, so the OS has some basic communication skills, maybe like basic phrase book French, but the specific drivers give it fluent, detailed instructions for each individual gadget. That makes sense for our GCSE understanding.
Right.
What about application and security management? How does the OS handle the apps we use and try to keep everything safe?
Right. Application management is essentially how the OS allows the different apps you use, your word processor, your browser, your games, to communicate correctly with both the computer's hardware, like accessing storage or using the graphics card, and also other software that's running on your system.
Okay.
It often does this through things called APIs, or application programming interfaces. Think of APIs as like standard sets of rules or connection points that allow different bits of software to talk to each other in a consistent, predictable way without needing to know all the internal details of how the other program works.
So they help apps play nicely together.
In a nutshell, yes. And then security management. This is obviously crucial. It's all about protecting your computer system and your personal data from unauthorized access, malware, things like that.
How does the OS help with that?
Well, it allows different users to log in with their own separate accounts, right? And the system administrator, which is often just you on your home computer, can set different access rights or permissions. These control what each user is allowed to do with specific files, folders, or programs. Can they read it? Can they change it? Can they delete it?
Okay. Like on school computers sometimes?
Exactly. The OS also keeps track of individual user settings like your desktop background, your saved passwords in a browser, securely, hopefully, your documents, keeping them separate from other users. And it can sometimes even monitor or log what's happening with files, who access what, when, which can help identify any security issues or unauthorized activity.
So it's managing who can do what and trying to keep everything separate and secure, a bit like having different user profiles on Netflix or something.
Yeah, that's a reasonable comparison. And finally, for our OS functions tour for the GCSE crew, we've got file management. This is something we probably interact with quite a lot, especially when we're saving our schoolwork.
Definitely. Saving files, finding files, losing files.
Hopefully not too much of the losing. File management is how the operating system handles the creation, organization, and access of all the digital files and folders on your computer's storage. That includes the main internal storage, like your hard drive or SSD, and any external drives, like USB sticks or external hard drives you might plug in.
So it keeps track of everything.
Yes, the OS keeps a sort of internal map, often called a file system, that knows exactly where all the bits and pieces of your data are physically stored on the drive. It also gives you, the user, the tools to do all the things you're familiar with. Creating new files for your essays or projects, organizing them into folders, perhaps by subject or date, giving them helpful names, renaming them if you make a mistake or change your mind, copying files, moving them around between folders or drives, and of course, deleting them when you no longer need them.
The trusty recycle bin or trash can.
Indeed. The OS also lets you control permissions on files and folders, deciding who else, if anyone on a shared system, can access, change, or delete your stuff. And crucially, it provides the search function, so you can quickly find that specific document you saved last week, but can't quite remember where you put it.
Very useful function. So the OS is like the librarian for all the digital stuff on our computers, keeping everything organized and easy to find. Hopefully.
That's the goal, yes.
Okay, that's a pretty thorough overview of the operating system for our GCSE listeners.
Yeah.
Brilliant. Now, there's another type of system software we mentioned right back at the start, utility software. What exactly does that do? And are there any specific examples our listeners should definitely know about?
Right, utility software. This stuff is designed to help you maintain, enhance, and sometimes fix problems with your computer system. Unlike application software, that's for specific tasks you want to do, like writing or browsing.
Yeah.
That utility software usually performs very specific, often quite limited technical tasks that help keep your computer running smoothly, efficiently, or securely. It often interacts quite closely with the hardware, especially things like your storage devices, and some utility software comes built right into the operating system itself, while other utilities you might install separately.
Okay, so it's about system health and performance. Can you give us a few key examples of common utility software and explain what they do in a way that's easy for our GCSE audience to grasp?
Sure. One classic example focused on maintenance is defragmentation software. Now, this is mainly something to be aware of if you're using older computers that have traditional magnetic hard disk drives, HDDs.
Okay, not the newer SSDs.
Generally, no. It's not really needed and can actually be slightly harmful for SSDs. But on a magnetic hard drive, over time, as you save files, edit them, delete them, the different parts of a single file can end up scattered in different physical places across the spinning disk. Little gaps get left behind when files are deleted. This scattering is called fragmentation. And it can slow down how quickly your computer can access those files because the read-write head, the little arm that reads the disk, has to physically jump around the disk platter to find all the different bits of the file.
So it takes longer to load.
Exactly. Defragmentation software essentially reorganizes the disk. It puts all the fragmented parts of each file back together in one continuous block and maybe tidies up the free space too. This means the read-write head can access the file much more quickly next time, which can improve the speed at which your computer opens those files or loads programs stored on that drive.
So it's like tidying up a really messy bookshelf, isn't it? Putting all the pages of the same book back together in the right order so you can read it more easily. Or like tidying your bedroom floor so you can walk across it faster.
Exactly. The tidy bedroom analogy works well. It just makes things more efficient to access. Another type of utility is compression software.
Compression. Making files smaller.
Precisely. This is designed to help you enhance your system, mainly by reducing the amount of storage space a file takes up, or making it faster to send over the internet. It uses clever algorithms, mathematical processes, to make the data more compact.
How does it do that?
Well, there are generally two main types of compression our GCSE listeners should know. lossy and lossless.
Lossy and lossless.
Lossy compression actually removes some data from the original file, usually data that the algorithm decides is less important or less noticeable to human perception in order to achieve a smaller file size.
So it loses some information permanently.
Yes. Once it's gone, you can't perfectly get the original file back. This is often used for things like images, like JPEGs, video, and music, like MP3s, where a slight loss of quality might not be very noticeable to most people, but the file size reduction can be huge.
Right.
Lossless compression, on the other hand, works differently. It reorganizes the data in a more efficient way, maybe by finding repeating patterns and representing them more shortly, but without losing any single bit of the original information.
So you can get the original back perfectly.
Exactly. When you decompress a file that used lossless compression, the original file can be perfectly recreated. This is obviously essential for things like important documents, spreadsheets, program files, anywhere you absolutely cannot afford to lose any data. Think of zip files, for example.
Gotcha. So lossy throws a bit away for size. Lossless just packs it more cleverly. What other useful utility software should our GCSE listeners know about?
Encryption software is another important one. This helps enhance your system's security.
Encryption, making data secret.
Pretty much. It basically scrambles your data. It turns readable, plain text into a jumbled, unreadable mess called ciphertext. It does this using a special algorithm, which is like a secret recipe, and usually a unique key, like a password or a secret card.
Right.
Only someone who has the correct key can unscramble the ciphertext and turn it back into its original readable plain text form. This makes your data much more secure if your laptop gets stolen or if you're sending sensitive information over the internet.
Right, so people can't read it without the key.
Exactly. And finally, a really useful piece of utility software that's often built right into the OS, certainly on Windows and macOS, is the Task Manager on Windows or Activity Monitor on macOS.
Yes, I've used that when something freezes.
Exactly. It's use case sometimes. It allows you to see exactly what your computer is doing at any given moment. You can monitor how it's using its resources, things like how busy the CPU is, how much RAM is being used by different programs, how much the hard drive or SSD is being read from or written to.
What can you see in there?
It typically shows you a list of all the programs and background processes that are currently running, how much processing power and memory they're each using. It can be really helpful for troubleshooting if your computer is running slowly, or if an application has crashed and become unresponsive. You can often use it to force quit the misbehaving program.
Yeah, the end task button.
That's the one. It can also give you a snapshot of overall system performance, maybe a history of app usage, show you what programs are set to start up automatically when you turn on your computer, which can slow down boot time, which users are currently logged in, and even lists of background services that are running. It's a powerful tool for seeing what's going on.
So the task manager is like having a peek under the bonnet of your computer to see what's going on and helping you spot if anything is causing problems or hogging resources.
That's a perfect way to describe it, yes. Under the bonnet.
You gave a quick example earlier about a hotel booking system and fragmentation, just tying back to that defrag utility. Could you just quickly remind our GCSE listeners how that sort of thing happens in a real-world scenario they might be able to picture?
Right. Yeah. Imagine that hotel booking system storing all its booking details as digital files on its server's hard drive. When a new booking comes in, the details are saved as a new file, right? It needs a certain amount of space. Over time, as guests check out, their old booking records might be deleted from the system to free up space. That leaves little empty gaps on the hard drive where those files used to be.
Right. Holes appear.
Exactly. Now, when new bookings are made later on, the system might try to fit the new booking file into one of these empty gaps. But what if the new booking file is bigger than the gap available? Then the file might have to be split up. Part of it goes in one gap, another part goes in another gap further down the disk. The file becomes fragmented, split into multiple pieces scattered across different physical locations on the hard drive.
I see.
So gradually, as bookings are constantly made and then deleted over weeks and months, the files holding the booking data can become more and more fragmented. This means the computer, the server, has to work harder and take longer to piece all the bits of a booking record back together every time the hotel staff need to access that information. This can lead to the whole booking system feeling like it's running more slowly overall.
That makes a lot of sense. Yeah, the tidy bookshelf or tidy room analogy really helps picture that fragmentation issue for our GCSE listeners. Okay, wow, we've covered a huge amount of ground today, looking at both the physical hardware and the all-important software. Let's just quickly bring it all together as a final takeaway for our GCSE crew.
Absolutely. I think the number one key takeaway for your GCSE is to remember that hardware and software are completely interconnected. They're partners. They absolutely need each other to be useful.
Yeah, one without the other is pretty pointless.
Exactly. The physical components, the hardware can't do anything intelligent without the instructions provided by the software. And the software itself needs the hardware to run on. It can't exist in isolation. It needs the processor, the memory, the storage.
And we've seen how system software, especially the operating system, with all its different critical roles, managing the user interface, the memory, the processor, all the devices, the application security, and our files.
Mhm.
And also that utility software, which helps to maintain and enhance the system. They all play such a vital role in managing all the computer's resources and providing that, well, mostly user-friendly experience that we're all familiar with now.
Totally. The OS really is the unsung hero, isn't it? Constantly working away in the background, juggling all these complex processes so that you can just focus on using your apps, whether it's for schoolwork or gaming or keeping in touch with friends without having to worry about all the incredibly complex technical details going on underneath.
Definitely gives you a new appreciation for it. So now that you've hopefully got a better understanding of what's going on under the bonnet of your computer for your GCSE studies, here's a final thought perhaps to ponder.
Ooh, okay.
Thinking about all the different bits of tech you use every single day, your phone, your tablet, your games console, your laptop. What's one aspect of how they actually work that you find particularly interesting or maybe even a bit surprising now that you know a bit more about the hardware and the software working together?
That's a good question.
Perhaps it's how quickly your phone seems to switch between different apps, or how your smart speaker seems to understand your voice commands most of the time, or maybe just how clicking save actually stores your work reliably. Have a think about how all these different components, the hardware, the operating system, the utility software, the applications, all have to work together perfectly in the devices you rely on every single day. It's a pretty amazing bit of engineering when you really stop and think about it, isn't it?
It really is quite incredible. Food for thought, definitely.